Alright, sorry if you can hear my washer going. I am at home doing laundry, and it's really loud to me. I just hope it's not picking up on the video. Alright, so this first section here is on gathering and organizing information. So I'm just going to go over different kind of samples, and then we'll kind of classify different scenarios. So a simple random sample is chosen in a way that every unit in the population has an equal chance of being selected. And the chances of a unit being selected doesn't depend on the ones already chosen. So, drawing names out of a hat. I could put everybody's name in the class in a hat, shake it all up, and that's our population. And then me pulling names from a hat to make a group. That's a simple random sample. Right? A systematic random sample. It has an ordered list. So instead of just throwing names in a hat, maybe I'm looking at the list of names in alphabetical order, or by your student ID. And then I'm going to figure out what proportion of the population I want in the sample. And so that can make a proportion. So 1 in every 3, or 1 in every 5. A stratified sample is one chosen so that particular groups in the population are certain to be represented. So let's say we're looking at a large high school and we want to choose a sample of 12 students. For the stratified sample, we're going to divide them into groups called strata and then take a random sample within each stratum. So in the high school example, we could divide it into grade levels, so 9th, 10th, 11th, 12th. And then we could pick 3 students from each grade, which would give us the 12 we need to do our sample. A cluster sample is where clusters of units are chosen at random instead of individual units. So let's say we have college students, and we may take a list of all the course sections being offered at the college and choose 3 of them at random. So those sections are the clusters. And then we're going to survey all the students in those sections. So a sample like this has an advantage of being convenient. And if the survey needs to be administered in person, many of your sample units will be located in one place at one time. Okay, so let's look at some scenarios here and decide whether it's a simple random sample, a systematic random, a stratified, a cluster, or none. Alright, so we have a postal inspector wants to check on the performance of a new mail carrier. So she chooses 4 streets at random among those that the carrier serves. And then each household on that selected street receives a survey. So we've put them in to, let's say there's like, how many did I just draw? 1, 2, 3, 4, 5. Let's say there's 6 streets that this mail carrier serves. Well, the person has chosen 4 of those. So 1, 2, 3, 4. And we're doing all of the houses in those. So this is actually going to be a cluster random sample because we're taking the entire groups. Now, if we were to take 3 houses here, 3 houses here, 3 from each one, then that would be stratified. So the hospital wants to survey past patients to see if they're satisfied with the care they received. An administrator sorts the patients into groups based on departments and then selects patients at random from each of those groups. So kind of how I was just describing with those streets. We are in different groups, but then we are taking some from each. So this is a stratified. A quality control engineer at a factory that makes smartphones wants to figure out the proportion of devices that are faulty before they're shipped out. The phones are currently packed in boxes for shipping, each of which holds 20 devices. The engineer wants to sample 100 phones, so he selects 5 crates at random and tests every phone in those 5 boxes. This is another one where it's a cluster because you're taking the entire group of them. Or a newspaper reporter wants to write a story on public perceptions on a project that will widen a congested street. Stands on the side of the street in question and interviews the first 5 people she sees there. So that is none of what is provided, but what it is, it's called a convenience sample. So you're taking the first 5 people in the area of interest. An executive at a streaming video service wants to know if her subscribers would support a second season of a new show. It's a list of all the subscribers who have watched at least one episode and uses a random number generator to select a sample of 50 people from that list. So, that is just a simple random sample. An agent for a state's Department of Revenue is in charge of selecting 100 tax returns for audit. He has a list of all returns eligible for audit, about 12,000 in all, sorted by taxpayer ID number. He asks a computer to give him a random number between 1 and 120, and he gives him 15. So the agent chooses the 15th, 135, 255, 375, and every 120th after that is to be audited. So it's an ordered list because it's taxpayer numbers. And then we're taking 1 and 120. So let me say that. It gives them 15. So getting 15 groups. Okay, I'm a little backwards here. Hang on. Between 1 and 120, it gives them 15. We're choosing the 15th, the 125th, 255th. So we started out counting out to the 15th one, and then we went out 120, and then 120, and 120, and so on and so forth. So this is a systematic. The ordered list, or the ID numbers, should have been the first giveaway for this to be systematic. All right, we have some types of data. We have categorical and we have quantitative. So categorical means the data can be sorted into like categories, or categories are used to describe them. So like eye color, yes or no questions, shoe size. I shouldn't say shoe size because that's a number. Color of like clothes they're wearing, hair color. Let's see, quantitative, that's that number one. So the shoe size, like I just said, was actually quantitative. Let's see, what else could be? Height, weight, number of rooms in a house, square footage of houses. And then all this data can be organized in different ways. So we have a categorical frequency distribution. We can make a table with 2 columns. First one has the category, and then the second one has the frequency. So here's an example. Here we'll do. So a teacher records the responses of the class. There's 28 students. Let's see, the first question of a multiple choice quiz has 5 answers, A, B, C, D, and E. And we're going to create a frequency chart based off of this information. So we can label this as choice. And we have A, B, C, D, and E as choices. And then this would be the frequency. So I'm going to count up how many of each letter there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 A's. You might see it as numbers, or you might see it as tally marks. Either one, totally fine. Let's do B. 1, 2, 3, 4. C. 1, 2, 3, 4, 5, 6. See any D, and then 1, 2, 3, 4 E's. And because we have 28 students, this total right here should add up to 28. So let me see, 14 and 4 is 18, and 18 and 10 is 28. So we've accounted for all the information we need. Now we can do the same thing for quantitative data. we just have numbers as an answer. So this is, let's see, attendees of a conflict resolution workshop are asked how many siblings they have. So, number of siblings. And what are the options? We've got 0, 1, 2, 3. What's the highest number? I think 5 is the highest number. And then we can do the same thing here. So we have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 ones. 1, 2, 3, 4, 5, 6 twos. 1, 2, 3 threes. 1, 2 fours. And then 1, 5. So this one didn't give us a total number here, so we can add that up. So 5 and 13 is 18. That's 20. 30. And we have something called Bind frequency distributions. So these are GPAs of students that are enrolled in advanced sociology class. All these GPAs are all in like decimals, and I don't want to have a frequency chart of like every single data value, right? So I might want to bin them up. So GPA and frequency. And in this case, let's see, what's the lowest? Trying to do a quick scan here. We have 1.20. Okay. And what's the highest? Probably a 4. Are there any in the 4s? Doesn't look like it, but 4 is usually the highest GPA option. So what I want to do here, so I would say we're going to range from 0 to 4. We want the bins to be of equal length or width. And because these are in decimals, I don't want to go 0 to 1, 1 to 2, etc. I probably want to go in smaller chunks. We could go from, how about 0 to 1.49, and then 1.50 to 1.99, and then 2 to 2.49, 2.5 to 2.99, and then 3 to 3.49, 3.5 to 4. Could go smaller, but I guess typically halfway in between them would be a good idea. So now let's just find all the numbers that are between each interval. So 0 and 1.49. So 1, 2, just 2. 1, 2, 3, 4, 5, 6. See, 2 to 2.49. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 to 3.49. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 5, 6, 7, and that's a 4, 9, so that should go up here. So 10. And then let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 by 1, 3, so there should be a total of 36. So I'm going to add this up real quick. So we got 10 and 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 36. All right, so we have 36. Accounted for them all. All right, I'm going to look at these and figure out what category they go in. Do they fall into quantitative or categorical? So quantitative, I'll just put a Q. Categorical, I'll just put a C. And so let's figure out what goes where. The color of an M&M candy. It's going to be in colors, so it's going to be categorical. How many miles a person walks in a day? Quantitative. The age of a mother when her first baby was born. Also a number. Whether or not a car has automatic transmission or manual. Categorical. The number of calories in a pint of vanilla ice cream. Quantitative. The number of dogs an animal shelter has. Quantitative. The weight of an airplane. Quantitative. Life expectancy. Also quantitative. The length of a snake. A lot of these are turning out to be quantitative, so I'm going to change that to, instead of length of a snake, we're going to put type of snake. Give me categorical. Diameter of a pizza. Quantitative. And number of books the person owns. Also quantitative. Alright, if you have any questions, let me know.